Hi, I'm Grace Kaikwad. My project builds a multi-agent generative AI framework that builds an ETL pipeline and crucially proves they're correct, using formal rules and human sign-off. I'll cover the idea and results in the slides, then show the code, then the live dashboard demo. Starting off with the problem that we face while doing an manual ETL pipeline. Building an ETL pipeline by hand is slow and error-prone. Generative AI can write the code fast, but it hallucinates. The code can be syntactically valid, yet semantically wrong. A pipeline that silently is wrong is worse than none, because the errors spread downstream. So I target the middle ground, and AI does the work, but its output is measured and gated. Moving on to the framework. So as you can see, this is a framework of my ETL pipeline project. The data flows through five specialized agents. The profiler diagnoses the raw file. The generator uses a live LLM to write the pandas cleaning code. The validator runs it in a sandbox and scores it against six rules. The critic explains why the failure the synthesizer rewrites the code, looping until all rules pass. The key principle here is the agent that writes the code is never the one that approves it. The validator is deterministic, a fixed rule book so that AI can't mark its own work. Moving on to the formal validation. Correctness becomes a number. Six objective rules are nothing but the required columns, data types, missing values, duplicate, derives attributes, and invalid output. The fraction passed the validation, success score, and the same layer scores every approach so comparisons are like for like. After these rules, we have the human in the loop. A tired gate, a perfect six of six to approve. A single rule miss is escalated to a human to approve or reject. Anything lower is rejected and refined again. Every decision is locked and the download is locked until it's approved. Human effort is spent only where confidence is low. As you can see, the 100% 6 on 6 rules is auto approved released immediately. Approximately 83, which is 5 out of 6 rules are passed. Human approved. So the human has to approve, edit, or reject the code. Below 83 is sent back to the synthesizer to rerun and correct the code. Now, moving on to the datasets and results. I evaluated on two large real datasets, CMS Medicare over a million records and CFPB 854,000, that is 1.87 million rows in total. The headline results both datasets pass all six rules, 12 out of 12, 100% validated. Head to head on the same imperfect draft, a single agent leaves about 1,500 defects, the multi-agent loop repairs them to zero and reaches 100%. So the win is correctness guaranteed, not luck. And pays off downstream, a classified train on the clean CFPB data hits approximately 0.92 ROC, AUC, and 85% accuracy and scores 5 runs. Validated data consistently beats unvalidated. Validation isn't bureaucracy, it measurably helps. Moving on to the code. This is the agent of .py. 1, 2, 3, step. This is the agent.py. The agent turn class at line 13 to 20 is a shared message from every agent uses to pass results between each other. The generator, as you can see, the generator class takes the ETL requirement and asks the LLM to draft the first transform function, followed by the critic agent reads the validation feedback, specifically checking for any fail flags and explains what went wrong. The synthesizer, lastly, takes the critic feedback and writes the broken transform to fix the failing rules. Together, these three agents form the generate critic fix loop that makes the framework self-correcting. Moving on to the spec.py. This file defines the dataset configuration and tells that every agent what the clean output should look like. The dataspec class at line 12 is the blueprint. It holds the required columns, data types, primary keys, and the reference column and the reference function for each dataset. The CFPB reference, as you can see at line 50, the CFPB reference and CMF reference transform at line 88. Here is CMS reference are the gold standard cleaning functions. They cast types, fill nulls, compute derived columns like days to forward at line 66 and average payment for service at line 101, then drop duplicates. The derived checks at line 120 and 30, and 130 are the custom validation rules. For example, verifying the timely flag actually means timely response. Finally, build generic at line 155 handles any uploaded CSV automatically. It informs column types and builds a cleaning function on the fly, making the framework dataset agnostic. Now we have the sandbox.py. This is the file this is a file in which secure execution sandbox it safely runs AI generated code without letting it harm the system. At line 10 to 9, 10 to 19 define whiles of allowed Python built-ins, things like length, sum, and instance. This means the generated code cannot import dangerous libraries or access the file system. The extract code at line 23 pulls the Python block at line 23 pulls the Python block out of the LLM response by stripping the markdown fences and removing any important statements at line 27. The main function at line 31 compiles and executes the generated code at lines 38 to 40, then checks that it actually defines a callable transform function at line 45. Most importantly, lines 51 to 57, as you can see, lines 51 to 57 runs the transform inside a background thread with a 30-second timeout. So if the AI generated code hangs or crashes, the system safely recovers rather than freezing. Validator.py. This file renders the validation rules page of the Streamlit dashboard. Lines 8 to 54 Lines 8 to 54 define the six formal rules, R1 through R6, each with what it checks, why it matters, how it verified, and an example failure. These are the same rules that run inside the agent pipeline. The render function at line 48 The render function at line 48 builds the entire page. The rules explorer at 80 to 91 lets check anyone click a rule and instantly see its full definition, making the validation transparent to non-technical users. Line 95 to 115. Let's move on to line 95 to 115. Yeah. Lines 95 to 115 load the live validation report and build the heat map. Green for pass, red for fail. So you can see at a glance that all 12 checks across both datasets pass. Finally, the headline metric at 130 to 137. Moving on to line 130 to 137. Here, displays the overall validation success score, the single number used to compare manual, single agent, and multi agent approaches. Now, the orchestra.py. The orchestra runs the loop profile, generate, validate, critic, synthesize, rescoring each iteration until all rules pass or the budget is spent, then applies the confidence gate. Lastly, we have the train.py, and this is where the results come from. It runs the multi-agent framework against a single agent baseline on the same imperfect draft, then trains the downstream relief prediction model on validated route versus unvalidated data. That's the 0.92 AUC and the validated versus unvalidated comparison you saw. Moving on to the dashboard. The multi-agent AI framework. Five AI specialists work together to clean the AI data automatically. One diagnoses the raw data, that is profiler. One writes the cleanup steps, that is generator. One checks them, that is validator. One spots them, that is critic, and one fixes them. And a person approves the result. Here, this is nothing but the overall work of what the five AI agents do. The profiler, generator, validator, critic, and synthesizer. Moving on to the generative pipeline. This is AI written pipeline. A large language model actually writes the data cleaning steps, checks them, spots problems, and fixes them. Watch the four agents but a trustworthy step by step, results step by step. So as of now, I have taken 2000 sample rows and it is on multi-agent full loop. We also have an option to select how many rows you want to run. So I will go for 2000. I will just keep it as it is and we'll just run the pipeline. As you can see, the final validation is 100%. The approval step is approved, and the runtime is 0.39 seconds. We also have the threshold value that is 90%. So there was no need for any human in the loop intervention. And this is the agent trace. Each agent, the profiler, generator, validator, and the synthesizer, whatever work they have done, it will be displayed on this. Moving on to the star of the demo, that is clean a CSV file. Here, I will give you the full demonstration of how we load a raw file and what do we do exactly with the clean CSV file. So we can simply just browse the file from here, take the metadata, and we'll just run to clean the file. We can also preview the raw data from here to check what was wrong. And as we can see, this part gives you what they have found in your file. There are 9 rows, 4 columns, 1 duplicate row, and 4 column issues with issues. This is nothing but the data profiling report. You can download the data profiling report from here, and it will look like this. Moving on to approve and review and approve. Each cleanup is scored out of 100. A perfect score is approved automatically. A near miss goes to a person to check, and a low score is sent back to clean again. So this is nothing but the 100% is approved, 83 to 99 is sent back to person, and below 83 is sent back to synthesizer to clean it again. Let's approve and release it. And yeah, so the clean CSV file is ready to download. So the clean CSV file looks like this. Before, we had a preview of our dirty or untidy CSV file, which looked like this. And after cleaning it, the CSV file somehow looks like this. Moving on, this clean CSV file can be used to just download and use for Power BI and Tableau. We can also download the data quality report and from here. So this is how the data quality report looks like for the clean data CSV file that we have got. Formal validation. The formal validation page shows the 12 out of 12 pass metrics for both data sets and model results, shows the downstream classifier. The 0.92 AUC, the confusion matrix, and the validated versus unvalidated comparison, and proves the clean data trains a better model. So this is nothing. There are 6 rules that have been mentioned here, and you've also got the 6 rules and their explanation and what work they do here. So this is nothing but the 6 rules that the data has to pass through. And any one of these rules, like if the result is between 83 to 90, 83 to 99, that is one of these rules might just fail. Lastly, to summarize, combining multi-agent reasoning, formal validation, and human oversight makes generative ETL measurably trustworthy. 100% validation, zero residual defects versus 1500 better downstream models, and a real-world tool with reports and BI export. Future work is a live LLM evaluation learning from the human gate decisions and big data streaming. Thank you.